Hello students, we're going to make a quick video on the review sheet. Okay, so a car has initial speed of 15 meters per second. It slows down for 3 seconds until it stops. Very important that you understand that it stops, because that means that the final velocity is 0. What is the distance? So s equals question mark, u equals 15 meters per second. Time equals 3.0 seconds, and the final velocity is 0. I'm going to use this equation. This is the equation we're going to use for a lot of our equations today. Then I'm going to substitute the values right into the equation. So s equals 15 plus 0 divided by 2 times 3. Okay, so I'm going to get my calculator out. That's going to be about 7.5 times 3. So let's see here. S equals 7.5 times 3, about 22.5. That sounds about right. And that's in meters. Okay. A block of mass 2 kilograms accelerates from a speed of 16 meters per second to 24 meters per second without changing its direction while traveling 4.5 meters. How much time has passed? So we're going to use the same equation. We're going to label our knowns. So we know the initial speed and we know the final speed. I'm just going to write the numbers for here on out. Okay. And then we know the distance, but we don't know the time. So I'm just going to plug in my values, 4.5. Oh, by the way, we don't care about mass. So these problems are kind of like hinting at future problems where we will need to know about mass, but in this question you don't. 16 plus 24 divided by 2 times t. Okay, so we're going to use some algebra. Basically, we're going to solve for this part here. So 16 plus 24 is 30. 30 divided by 2 is 20. And then we get t here. And then t equals 4.5 divided by 20. And then t equals, get the calculator out, roughly a quarter of a second, a little bit less. So 4.5 divided by 20. 0.225 seconds. Okay. Now, if we do look at the significant figures, we see that each of them only have 2. So you can actually round this to t equals 0.23 seconds. Net force. We don't care about force. We're going to study force later on, and we don't care about mass. We do care that it says rest. So if something starts from rest, its initial velocity is 0. And then t equals 2.5 seconds. All right, so what is the displacement? All right, so we're going to use that formula again. We don't know s. We know initial is 0 plus 5 divided by 2 times 2.5. And so s equals 2.5 times 2.5 is 6.25. We're just going to go ahead and round to the 6.3, and that's in meters. Because again, if you see, all of the numbers given are in 2 significant figures. All right, so I had a lot of questions about this boat. So I'm going to draw a picture. Here's the boat. Now the boat wants to go like this. That's what the boat wants to do. So that's like the resultant vector of what the boat is doing. But the boat has another vector acting on it, which is this. This is the river. So I'm going to call this the r vector for river. All right. And then we'll call this the b vector for the boat. But it says, which way do we steer? Because if we try to steer directly across the river, we're going to go at an angle. And we don't want to go at an angle. We want to actually go straight across. So then we have to steer this way. The reason we have to steer this way is because the red vector with the green vector the red vector cancels out the green vector, and then what's left is this horizontal vector. Okay? So basically, the r vector plus so the green vector is the steering vector, so that's how we're going to steer. Plus the steering vector will equal what the boat actually does, the boat vector. You can kind of see this in like thinking about like which way the vectors are broken up into. So the green vector is kind of broken up like this and like this. And you can see like the downwards green part cancels out the redwards up part, and what's left is the greenwards over part. Anyways, the point is that we're going to steer southwest. Okay, so the answer is southwest. All right, number 5. This question had acceleration in it, which we don't really need to know, and it has mass in it. So we're just going to focus on that the elevator starts at 0. Now, when you get on the elevator, it has 0 velocity. When you go up, it starts to speed up. But we don't care about the acceleration. We just care about what's the velocity when it passes the second floor. So here is the displacement, and here's the time. So if we put that into our equation, we have 4.26 equals 0 plus v. We don't know v. V is question mark. Divided by 2 times the time, which is 2.5. Now you're going to do some algebra here. So multiply both sides by 2 and then divide by 2.5. Here, I'll show you step by step. So 2 times 4.26 is going to be 8.52 equals v times 2.5. Okay, now we're going to divide both sides by 2.5. And then we're going to get v equals, let's see here, 8.52 divided by 2.5. We're going to get v is equal to 3.4. Oh, and that's in meters per second. All right. As the elevator goes up to this, it passes the second floor, so like it continues on, right, past the second floor. So it's not slowing down to go to the second floor. It's just continuing on going up. So maybe it's going to the third or fourth floor. All right. Here's a graph. This is a velocity versus time graph. We haven't done too many velocity versus time graphs, but basically it's just showing the velocity as time goes on. This is not to be confused with a distance versus time graph. After 15 seconds, the boy has run 50 meters. What is the instantaneous velocity at time 15? So here is 15. So here's the instantaneous velocity. That velocity is equal to 5 meters per second. So that's the first answer. We'll say that's the part A. Part B says, what's the average velocity? Well, average velocity is equal to the total distance over the total time. So the average velocity equals the 50 meters over the 15 seconds, which is equal to, I believe it's 3.3 repeating. So 3.3 meters per second is the average velocity. Okay. I noticed that some students were looking ahead and that they noticed that this shaded area here is 25 meters, and then this shaded area here is 25 meters. So the area shows the distance. That's kind of like a preview of what you're going to learn in the next unit.